Hello, everyone. Good morning, good afternoon, wherever you are in the world, and welcome. Welcome to the September edition of Azure Cache for Redis Community Standup. And today we'll be talking about how to use Azure Cache for Redis with your applications hosted on Azure Kubernetes service. So, some quick recaps. You can reach out to us. Hang on, something wrong with my slides. My slides won't move. Hmm. Anyway. Um, anyway, let's skip the presentation mode and let's just do it from the app itself. Anyway, you can reach out to us at Azure Cache PM at Microsoft.com. And if you have any questions, it's a live video. So do post in your questions in the chat and we'll get back to you as soon as we can. So quick recap, what is Redis? Redis is an open source in-memory key value NoSQL data store which allows you to do very simple set key value and get key value commands. And because it's in memory, it will it can give you sub-milliseconds of latency and can effortlessly scale out and provide massive throughput. And also the key value design is super simple and it has been popular for a very long time, and it's perfect for caching and storing ephemeral data. So, couple of use cases where Redis gets heavily used, but because the theme of today's session is Kubernetes applications, I'll focus on the use cases where Redis is used most for Kubernetes applications. So the first one is reducing database access costs. That's a no-brainer there. You can complement any database with Redis, and it will help accelerate your databases. And user session data store, that's also one of the very common use cases where Redis is heavily used. Other use cases are caching responses from third-party API calls or any API calls for that matter. And then for microservices specifically, storing the state across microservices and sharing the state across microservices. That's another very valid use case for Redis Cache, along with accelerating your stream processing and then optimizing memory requirements for your Kubernetes pods. Redis can also be used for vector similarity search and creating your own ChatGPT or LLM kind of applications. So these are the most common use cases where we see Redis being used with cloud native or Kubernetes applications. I actually have a couple of samples here of what these looks like in real life. For example, the Adobe's cloud document service team has multiple microservices hosted on Kubernetes, and those microservices talk to MySQL, Cosmos, and Azure Cache for Redis. And in this case, Azure Cache for Redis is actually used to accelerate these databases as well as store the state information across these microservices. These databases and Azure Cache for Redis is provisioned using Azure Service Operator. That's one of the topics that we'll cover later today. And then the second example architecture that I have is from Bosch. This is for their wrong way driver warning service. As the name indicates, it has to be real time and has to process a lot of IoT telemetry to make this warning system efficient and useful. Redis here is used for accelerating the stream processing, the stream of data that comes from IoT telemetry. Redis helps quickly map the device to a customer, like which device is this telemetry coming from and who is this customer, so that we can proactively or actively notify the customer immediately as soon as we detect there's a wrong way driving happening. So as you can imagine, this is a super latency sensitive scenario, and Redis works very well in this scenario. Since Redis is open source, customers or you or the developers have a lot of options of how to deploy Redis, right? Like you can have the Redis images running into containers on your Kubernetes clusters, or you could just have Redis run on an Azure VM. But as you saw in the other examples, you could also use Azure Cache for Redis. That's the highlight here. Like, why would you use Azure Cache for Redis instead of hosting your own Redis containers? So the benefits are highlighted here. The major benefit is it drastically reduces the operational overhead of maintaining your own containers and keeping it up to date with security fixes and critical bug fixes. So Azure Cache for Redis automatically updates all cache instances periodically and makes sure your cache instances are up to date with security fixes and critical fixes. So it takes away your operational overhead there. And we have sophisticated strategies for BCDR, for your business continuity and disaster recovery scenarios. We offer built-in replication for the standard and premium tiers, so that provides a 3 nines of availability SLA. And then along with that, you can also configure your caches to be zone redundant or geo-replicated, which gives your caches resilience towards zone outages or Azure region outages. And then last but not the least, the enterprise tiers, enterprise and enterprise flash tiers, when they're configured correctly with the right zone redundancy and geo-replication settings, it can provide you 5 nines of availability SLA, which is an awesome SLA if you're looking to build very highly available applications. And then security wise, there's a lot of options for network isolation like VNet injections, private links, firewalls. You can use these to make your applications and your Redis instances more secure. There's also this passwordless authentication for the basic, standard, and premium tiers, which was introduced recently. So with the open source Redis does not have this option of passwordless authentication. So you are responsible for managing your access keys and rotating them periodically. But with this AAD based authentication, there's no need for maintaining or rotating access keys anymore. And then you also have this opportunity to leverage role-based access control, or RBAC, or Redis calls it ACL, access control list, and then you can configure your managed identity or service principal to have certain permissions to execute Redis commands. So both of these features are in preview and are being heavily used by a lot of customers to get rid of access keys altogether. In addition to the security features, there's also options to scale your cache instances seamlessly. So this means that your Redis instances will scale and support your growing workloads effortlessly. With self-managed or self-hosted Redis instances, this becomes a little bit of an overhead or a headache of how to manage your cluster of your Redis containers. How do you make it bigger? How do you make it larger? But with seamless scaling, it's scaling options in Azure Cache for Redis and Azure Cache for Redis Enterprise. This is now super simple. Azure Cache for Redis also supports triggering Azure functions now based on the data events or data updates happening in your Redis instances. This functionality unlocks a lot of scenarios for keeping your database and your cache in synchronization. And there's a lot of opportunities to reduce redundant calls to databases and accelerate your database calls altogether. So this is an awesome feature for using databases and Redis caches together. The next is the persistence to storage account. If you're familiar with the open source Redis, it offers an option to persist data to the disk where it's hosted. But with Azure Cache for Redis, you have these options to store or export your data to storage accounts, which makes it more portable to different regions, different applications. You can export data from one cache and then move it and then use it in a different cache in a different region. With enterprise edition, enterprise tiers, you're able to store data to Azure managed disks directly instead of the disks on the cache. So you're able to persist data more seamlessly into the Azure ecosystem with the Azure Cache for Redis and Azure Cache for Redis Enterprise options. We also have the console on portal where you can issue commands directly and securely through the portal. Otherwise, you would have to install a Redis CLI on a VM and then make sure it's securely connected to Redis and use the Redis CLI to run commands. But this portal makes executing commands super simple on the portal. And then last but not the least, you have out of box, very native Azure monitoring and alerting systems available for all your Redis instances. It makes it possible to correlate metrics with Redis and other applications running on Azure, and then have a consistent experience of of configuring monitoring and alerting for your applications. Plus, you get 24/7 world-class Microsoft support for your Redis instances. And we also partner with Redis Inc. For the support for enterprise and enterprise flash tiers. So those are the benefits of choosing Azure Cache for Redis. Uh, and then moving on, I would now that you understand, the benefits of using Azure Cache for Redis, I want to show you how easy or how simple it is to configure your AKS applications to connect with Azure Cache for Redis. So I have a couple of demos that we'll go through. So the first demo is a very simple AKS hosted application connecting to a basic cache. So the prerequisites obviously here are going to be, you're going to need a cache, a Redis Azure Cache for Redis instance. I have this cache called basic cache, and then you need a cluster, AKS cluster. So this tutorial is actually based on the popular AKS tutorial for creating a voting sample, a voting application. So what this application does is it will create a simple UI for some buttons. You can click those buttons for voting, and then your votes are actually stored behind the scenes in a Redis instance. If you look at this AKS sample closely, you will see that this sample actually uses a Redis container, a Bitnami image from Redis, and it's hosted on your Kubernetes cluster and along with your application, the voting application. So what we have done is we have slightly tweaked this YAML file, the deployment file. And as you can see, I have this updated YAML file. So instead of running the Redis in container here, we will eliminate this part where you are creating a Redis container. And instead, the application will connect to an Azure Cache for Redis instance. So it's the same YAML file, the same deployment. It uses the same deployment, but it does not create a Redis container. And if you check out, the environment variables have been slightly tweaked. So here you can see that the environment variables call out just the container Redis instance as the Redis, but we have replaced this with the endpoint for your Azure Cache for Redis instance, and then followed by the password to connect to it. So just these two small steps, and you will be able to apply this file. I forgot the name of the file. It's Azure Vote Sample. And then in a couple of seconds, you'll see that the service has been created, the deployment has been created, and we can, and then we can see how the application looks like. So it looks like that the service was created. This is the external IP where the service is running and exposed from my cluster. I'm going to open it up, and you can see that the voting app is actually running. And if you click on votes, you are actually storing this votes in the Redis instance. And if I go back to my basic cache, that's the cache that I'm connecting here. You can go to the console and run commands and see what kind of keys are in the cache. So for example, if I do get keys star, just keys, you can see the cats and dog command, the keys from the application getting stored here. So please keep in mind that this keys command is not safe to be used in production because it will scan through all the keys available in the cache. But you can see that this is just a demo, so I can easily use the keys command here. So if you try to get the value for this specific key, you will see it's 1. So if I update the value here again, if I vote for dogs a couple more times because I love dogs, and if I do get dogs again, you will see that the value has, oops, typo. You can see that the value has been updated. That means this is the cache that's connected to your Azure Cache, to your AKS application that's running in your Kubernetes cluster. So with small tweaks, instead of using the the container-based Redis instance, we were able to quickly change this to run with Azure Cache for Redis instance. So that's the simple demo of using how do you use AKS hosted applications with your Azure Cache for Redis instance. All you need is to configure your host name for your cache and then your access keys correctly, and your application should be able to connect seamlessly with your Redis cache. So the second demo I have here is a slightly more complicated scenario. This actually leverages the powerful active geo-replication that's available with Azure Cache for Redis Enterprise. So this geo-replication is very powerful in the sense that you can connect up to 5 caches into a replication group, and all these 5 caches are available for read as well as write commands at the same time. So you can create highly available scenarios where you share data across regions using your Redis cache, and then your application instances can seamlessly get data from any of your instance. For example, if you have, say, 2 instances of your website, say one running in Seattle and one running in New York, and then there was some outage in New York, so your database in New York went down or your Redis cache in New York went down. But you can seamlessly get that data from your Seattle instance in Redis cache for Redis instance, because the data is always replicated and in sync. So we're going to show this demo of how to leverage active replication with AKS hosted applications. Obviously, since we are showing geo-replication scenario here, the prerequisite is to have more than one Redis caches, Azure Cache for Redis instance. You will need, let's see, so this is my resource group, and the way you will create Azure Cache for Redis Enterprise here with geo-replication is just say Azure Cache for Redis Enterprise, choose it from Marketplace, and when you're creating it, you need to configure geo-replications group correctly. So for example, I'm going to say this is my demo cache in East region, and for tiers, I'm using the smallest of the enterprise tier, because this is just a demo. And then for the next steps, you can see in the advanced tab, you will need to choose a couple of things. So enable the non-TLS access, just because this is a demo scenario. For production scenarios, you'll definitely need to enable TLS only connections. And then clustering policy, we are choosing enterprise here because enterprise is straightforward and simpler for beginner scenarios. OSS is kind of more advanced and can let you do more advanced scenarios. But for our purposes, the enterprise clustering policy just works seamlessly for us. And then for active replication, you need to configure active geo-replication. Say you're going to create a new replication group, Redis replication group, and then configure this, and then go ahead and create the cache. In interest of time, I already have 2 cache instances created. So when you're creating the second cache instance, you use the same Redis replication group, and what you will end up with is 2 cache instances using the same replication groups. For example, I have this Redis East and Redis West caches that I've already created. And from the active replication blade, you can see that there's 2 caches in this group called Redis West and Redis East. And these are the exact same caches that I'm going to use in the demo. And then the second part of it is AKS clusters. So in real world production scenarios, you would ideally have 2 different AKS clusters running in 2 different Azure regions with 2 instances of your website. But since this is just a demo scenario, I have just a single AKS cluster, and we'll just have 2 instances of the application running in 2 different namespaces. So let's call them, we'll create 2 namespaces, create namespace East, and then okay, looks like I already created the East and the West namespace here. So that's great. We have those namespaces. So we'll just install 2 instances of the same application in the same AKS cluster, but under 2 different namespaces. And from the for preparing the deployment YAML, if you look at the deployment YAML, you will see a deployment that we have. we have an image that will run the website. And then on the other configuration, the environment variables, we have the Redis West cache and the password for it. And we are calling this as our Seattle cache, or the Seattle instance of our website. And along the same lines, we have, and then if you notice this application or instance will run in the West namespace. And exactly similarly, we have another instance which we will run in the East namespace, and it will connect to this cache, the Redis East cache, with the password for it, and then the location will call it Washington DC as the location. So if you run, let's apply it, kubectl apply. So let's run the application in West. So we have created the application in West, and then we will run the same application in East as well. Oh, I forgot the kubectl. How is it going to just apply the file without knowing how to apply? And then you'll run the same deployment for your East namespace, and you'll see that you now have a deployment and service running in the West namespace and a deployment and service running also in the East namespace. So what we'll do now is, now that we have the applications running and connected to the right Redis instances, we will load it up on our browser. So this is the endpoint for the service, the West instance of our service. So let's take this API, this IP, and put it up in our browser. So you can see this is the instance running on the West side, that is the Seattle side. And then we will have another instance running in East region, which is our Washington region. So another browser, and this shows that this instance is running in Washington DC. So now that we know that we have this application instance, two instances running in two different regions, and in this case, we just have a simple website, and you want to make sure that the inventory that you show for your customers in Seattle and the inventory that you show for your customers in Washington DC is synchronized all the time. So, for example, if a customer buys a T-shirt from Washington DC, you want to make sure that the inventory count is updated automatically and immediately for Seattle customers. So, for example, you bought one here and now you have just 10 available, and then the Seattle website is also now updated to show that just 10 instances or 10 count of this shirt are available. So if a customer in Seattle buys this, the customer in Washington DC also notices that the inventory count has been depleted by one. So this active replication here makes sure that the inventory data is always in sync between Seattle and Washington, with instantaneous latency, with very minimal latency, and you are able to keep your inventory count up to date all the time and avoid running into situations where you say you have inventory available, but there's no inventory left. I hope Amazon tries to use this technology, because I've run into cases where I bought an item because it showed up as available, and then later on I get a message saying, "Oops, we are out of stock." So, but anyway, so this is a great use case or a great scenario where you can use active replication to keep your data in sync. And last but not the least, we have another demo for Azure Service Operator. I mentioned this earlier in the session, but Azure Service Operator is essentially an open source project by Microsoft, which makes deploying and maintaining Azure resources super simple and straightforward. So I have these links all together. I'll post links to the resources later on. But Azure Resource, as you can see here, Azure Service Operator, it helps you deploy and maintain Azure resources through Kubernetes tooling. So there's a bunch of tutorials available here. We're going to focus on the Redis example here. So this is the same voting sample that we saw originally as the first demo. So we have the same deployment, the same application running here. And what we are going to do is, instead of manually provisioning the Azure Cache for Redis, we are going to mention or define in the same YAML file what Azure resources do we need. So here we'll see that first we want to create a Kubernetes namespace, but then we also want to create, oops, I clicked wrong things. I wanted to zoom in. Yeah, so we'll create a namespace called Azure Vote, but then we'll later on create a resource group. So this is an Azure concept. We are actually creating an Azure resource through a YAML file. So we want to create an Azure resource group, and then map that Azure resource group to this Kubernetes namespace. And then in this specific resource group, we want to create an instance of Azure Cache for Redis. And this is the name that we wanted to have. And we want it to be created in West Central US region. It has to be a basic C0 instance, and you can configure some other properties for your cache instance. And then notice that after the Redis instance will be created, there will be two secrets that will also be created or generated as part of the creation process. So the secrets would be Redis hostname and then Redis access key. So these two secrets will also be created in Kubernetes, in your Kubernetes cluster. And your deployment application, your deployment or your application container will actually use these secrets. So if you scroll down, you can see that my application is actually going to use these the secrets that were created after provisioning the Redis instance. So I'm using the Redis hostname and the Redis access key here. So the way it works is, as soon as I apply this YAML file, uh, the Azure resource creation will get triggered, and my application container will not get created unless and until the Azure resource has completed creation and the Redis host name and the Redis access key are available to be injected into this application. So since it takes a couple of minutes to create the resource and everything, I literally ran the same file, the Azure Vote Manage Redis, the exact same file that we were looking at. I ran it just a couple minutes before the sessions got started, and as you can see, it created a namespace, it created a resource group, it started creating a Redis resource, Azure Cache for Redis resource, and then the deployment and application. If you can see the pods wherein create container configurator, that means the creation is blocked until the Redis instance gets created. And if you look at it, it actually triggered creation. It actually triggered the creation of my resource group that I'm looking for. This was the resource group that was created just a few minutes ago. And we have this demo Redis, this Azure Cache for Redis instance, which was created using the ASO, the Azure Service Operator templates. So you can see this is the same basic C0 cache in West Central US that I have configured in the Azure Vote Manage Redis. This is the same file, this is the same resource group, and the same configuration that we configured here. And looks like the Azure Cache for Redis instance is now created. So hopefully this application is now running because it was able to get the secrets, the host name and the access key. Once the Azure resource was created, the secrets were injected appropriately in this application, and now this application is running. So you can see, we try to open up and see this application running. Let's see if this is running well. So we have this service that was created for this application, and let's load it up and see if it works fine. Yes, it's running the exact same application that we created originally. Let's try it again. So we are creating, this time I'm loving cats and not dogs. And we can go back and check the keys in this cache. This is the cache that was created through my Azure Service Operator provisioning. So if we do keys star, we'll see that there's again the cats and dogs keys that are available. And this time we love cats more, so cats will have a higher count. And then if you reset, both the counts will go back to 0. So if you do get cats now, you will see that the count has been reset. So this is the cache that's actually connected to the same application. It's the same application, the same Azure Cache for Redis instance, but it's just that the provisioning method used is slightly different. Instead of manually creating the Azure instances, Azure resources, we created them through the Kubernetes YAML here. So this will, we hope this will seamlessly or like simplify your provisioning and resource management to a great extent. Keeping your Azure resources requirements or Azure dependencies together with your Kubernetes applications. That's a great way to maintain all your dependencies together. And then you're able to apply these Kubernetes files. And then you don't need to have separate DevOps processes for your Azure resources and your Kubernetes resources. You can have the same way of deploying to your Kubernetes clusters, as well as maintaining your Azure Cache for Redis or any Azure instances for that matter. Another benefit of using Azure Service Operator is that once you rotate the access keys on your Redis instances, the secrets will be automatically updated in your Kubernetes cluster. And then when the pod reboots, it will pick up the updated access key. So that means you don't have to do the manual work of rotating the key for Azure Cache for Redis instance. And then maybe if you're storing it in Key Vault, go update it in the Key Vault, and then your pods can pick it up. But with this Azure Service Operator option, you eliminate a lot of manual steps, and you're able to get the rotated access keys in your cluster in a few minutes without any manual interventions required. So those were the demos that I had for you all today. And for resources, all of these resources are actually, I'm going to make this bigger. All of these resources have been consolidated and documented. All the points that we discussed about why to use managed Redis and where to find all these demos, everything is documented in this new blog post you can find with this AKS link. And then, of course, if you want to look for more Azure resources or what's new with Azure Cache for Redis, you can look up these aka.ms links. And again, reiterating, if you have any questions, reach out to us at azurecachepm@microsoft.com, and we'd be happy to hear from you. That's all the content that I had for today. Thank you all and have a great day. Looking forward to meeting again next month. Thanks all.